Hi everyone. Today we are going to give a look upon physical and chemical properties of the milk. Before starting with this topic, let's see what is milk, its composition, microorganisms present in the milk, and milk processing. So let's start our topic, milk and its composition. Milk used as a human food. It contains 87% water, 3.5% protein, 3.9% fat, 4.9% carbohydrate, and 0.7% ash. Okay. Milk protein consists of casein, mainly casein, and it exists in several classes alpha, beta, etc. If milk pH falls below 4.6, then the casein precipitate. Casein represent 80 to 85% of the total milk protein. Okay. When the precipitation occurs, the liquid portion referred to as whey. The remaining proteins are found in whey and include serum albumin, immunoglobulins, and alpha lactalbumin. Okay. So the mainly present protein is the casein. In addition to this, it also contains several other proteins in whey that are serum albumin, immunoglobulin, alpha lactalbumin, etc. Then the carbohydrate. It is 4.9%. Carbohydrate is lactose. Lactose is the main sugar, but smaller quantities of glucose and citric acid exist. The fat content varies between 3 to 5% and it is depend upon the cattle breed. Fat mainly composed of triglycerides composed of C14, C16, C18 and C18:1 fatty acids. Smaller quantities of diglycerides and phospholipids are also occur. Milk lipids exist in the form of fat globules, and these fat globules are surrounded by a phospholipid bilayer. Okay. The ash content is around 0.7% and it consists of high level of calcium and lower level of iron. Okay. Milk consists of non-fat solids 9%, total solids 12 to 14%. Okay. The pH of the milk is 6.6. Milk contain adequate supply of vitamin B with pantothenic acid and riboflavin. Vitamin A and D are added for human consumption and their presence has no effect on the activity of the microorganism. Okay. So the milk can be used as a human food, and it is an ideal growth medium for the heterotrophic microorganism and nutritionally fastidious gram-positive lactic acid bacteria. Okay. So it is an ideal medium for the growth of microorganism. Next, we can discuss the microorganisms present in the milk. Milk can be contaminated at any point in milk production process. Okay. Fecal contamination, bacterial contamination, physical contamination, and failure to detect abnormal milk, and also chemical contamination. Chemical contamination is from veterinary product, cleaning chemicals, non-food grade equipment. Fecal contamination is from soiled animals, especially teats, udders and tails. Bacterial contamination is from poor milking practices, soiled hands, soiled equipments, etc. Then the physical contamination is from milking machines, bulk tank, bedding materials, insects, animal hair, etc. There are several types of microbes are present. Some of the bacteria present in the milk are Micrococci, Streptococci, Corynebacterium boris, Salmonella, E. coli, and Bacillus. E. coli, Salmonella, and Bacillus are from animal feed or manure. Then Clostridium butyricum is from grain fed to the cows. Other bacteria include Campylobacter, Eusenia, Listeria, etc. Due to the moderate pH, that is 6.4 to 6.6 pH, good quantity of nutrients and high water content make milk an excellent nutrient for the microbial growth. Okay, so there are three reasons for the growth of microorganisms in the milk. First reason, moderate pH. Second reason, high availability of the nutrients for the growth. Third reason, high water content. Okay. The Micrococci, Streptococci and Corynebacterium boris are from udder interior teats. Okay. Then the molds present in the milk, which include Mucor, Aspergillus, Penicillium and Fusarium. Then the yeast include Deparomyces, Staphylococcus, Saccharomyces. Okay. So these are the microorganisms present in the milk. Milk processing. Milk is processed by a number of ways. Processing is done to produce cream, cheese and butter. Milk processing is by pasteurization process. Pasteurization is the destruction of disease-causing microorganism. But some endospores of Clostridium Bacillus are not destroyed. The pasteurization process is achieved by heating process. first heating process is the low temperature long time, LT. Okay, that is, the milk is heated to 63 degrees Celsius for 30 minutes. This is referred as batch method or LTLT. Then second one is the HTST, that is high temperature short time method. Here milk heat to 72 degrees Celsius for 15 seconds. This is called flash method. It is less destructive than batch method. Okay. So the batch method is more preferable. Okay. The basis of heating time and temperature is the thermal death time of spoilage organism. Then ultra high temperature or the UHT is the another thermal treatment that destroys non-spore forming pathogens in the milk. Some spore formers are reduced in number. Here, milk heat at a temperature of 135 degrees Celsius to 140 degrees Celsius. It is for less than 1 second. Okay. So the ultra high temperature treated milk is sterile with shelf life of 40 to 45 degree Fahrenheit. UHT treated milk is more flavorful due to the formation of Maillard products. Physical and chemical properties of the milk. It include pH, boiling point, viscosity, appearance, freezing point, refractive index, density, adhesiveness of milk, titrable acidity, surface tension, viscosity, foaming, taste, and specific gravity of milk. These are the physical and chemical properties. We can discuss each and every property related with the milk. pH. It is one of the physical property of the milk and it is ranges from 6.5 to 6.7. That is, it is at moderate pH. The pH of the milk is high or alkaline in outside of the milk than inside of the cow. This is due to the loss of carbon dioxide to the air. The pH of the milk never determined immediately after the milking. pH is determined after processing. Next one is appearance. Okay. Milk is opaque. Skim milk is more transparent and has a slight bluish color. The color varies from white to yellow depending upon the carotene content of the fat. Okay, so the fat contains carotene pigment. So the carotene content influences the color of the milk. Buffalo, goat and sheep have pure white color. Color is unindicative of purity and richness. The color of the milk depends upon the breed of the cow, feed fed to the cow, and quantity of the fat and other solids present in it. The carotene pigment provide yellow color to the milk, and it is synthesized from green feed fed to the cow. Okay. In case of buffalo, goat, the carotene completely break down to vitamin A. The breakdown occurs in liver. That is, carotene break down to vitamin A in liver. They lack carotene content. So their milk is pure white. Okay. I have already told that buffalo, goat and sheep have pure white color. Pure white color milk. Okay. This is due to the breakdown of carotene to vitamin A. Okay. In the case of cow, carotene is partially break down to vitamin A. The white color is due to the scattering of reflected light by fat globules, colloidal particles, and intensity of white color directly proportional to the size and number of particles in the suspension. Lack of fat globule give skim milk a bluish white color. This is due to the presence of a pigment known as riboflavin. Homogenized milk will appear more white than unhomogenized milk. Okay. So this is about the color of the milk. Third property of the milk is the freezing point. Freezing point of the milk is less than freezing point of the water. Measurement of the freezing point helps to determine if the milk has been diluted with water. Freezing point of the milk is 0.5 or 31 degree Fahrenheit. Okay. Let's move on to density. Density is the ratio of mass to volume. That is mass by volume. Okay. Density is depend upon temperature, composition of the material and inclusion of the air. The density calculation used for converting volume to mass ratio and also used to estimate solid content and to calculate other physical properties. Density of the milk varies from 1027 to 1033 kg per meter cube. That is 1.028 to 1.038 gram per centimeter cube. Okay. Fifth one is the titrable acidity. It is the amount of alkali required to bring the pH to neutrality. This property used to determine the bacterial growth during the fermentation process. That is, the bacterial growth during cheese fermentation, yogurt fermentation, etc. Titrable acidity is due to the casein and phosphate. Next property is the Viscosity. Viscosity of the milk used for checking the rate of creaming, rate of mass and heat transfer, and flow conditions in dairy processes. Viscosity is dependent upon pH and temperature. Viscosity is the reverse of fluidity, that is the resistant to flow. It is expressed in terms of relative viscosity. Milk is 1.5 times more viscous than water. Okay. It is due to the presence of solids in the milk. So the milk is more viscous than water. The temperature increases causes viscosity decrease. At 0 degrees Celsius, fluidity of the milk is 0.233. At 0 degrees Celsius, fluidity of the water is 0.55. If the fat content is high, then the viscosity also high. It is due to the high solid content. Souring, aging, and microbial growth also affects viscosity. Seventh property is the taste. Milk is slightly sweet due to the presence of lactose. It is balanced against the salty taste of chloride in the milk. Both are mediated by proteins. The chlorine content ranges from 0.6 to 0.12%. Next property is the odor. Milk have a characteristic odor. Freshly drawn milk have curvy odor which disappear when kept exposure. Milk acquire odor from surrounding, abnormal feeding, bacterial contamination, and change in chemical composition. Next, we can move on to boiling point. Boiling point of the milk is heavier than water. Boiling point is influenced by protein, fat, etc. Then the boiling point of milk is greater than water. That is, boiling point of the milk is 100.17 degrees Celsius. But the boiling point of the water is 100 degrees Celsius. Okay. Next factor is the refractive index. Refractive index of the milk is 1.35. Then the refractive index of the water is 1.33. It is used to measure the concentration. Therefore, the addition of water lowers the refractive index of the milk. But considerable variation occurs for genuine milk. So it is not possible to use this property to check the genuineness of the milk. Another property is the adhesiveness of the milk. A piece of paper is moistened with milk, then stick to a flat surface of wood, glass, or metal. This property is due to the presence of casein. So the casein helps to adhesive or the addition. Okay. Surface tension. Surface tension of water is 72.75 dynes per at 20 degrees Celsius. Surface tension of milk is 50 dynes at 20 degrees Celsius. It decreases with increasing temperature and fat. In the case of skim milk, surface tension increases. That is, skim milk is the milk without fat. So the fat removal causes the increase of the surface tension. Cream also has lower surface tension. Okay. Next one, foaming. Milk has the property of foaming. It is formed on agitation. The capacity for foaming is due to the materials lowering the surface tension. That is milk protein and fat. Milk fat also increases the stability of the foam. Milk foam is unstable and break down when allowed to stand. Last factor, specific gravity of the milk. The specific gravity ranges from 1.028 to 1.032 and it is dependent upon the protein and fat. Now we have covered 14 different physical and chemical properties of the milk. I think you understood this topic. Thank you. Thank you all.